All right, this is the math team practice again. These are the questions from the October 8th Alamatic Math Tournament. We got through 13 on Tuesday. We're starting on 14 today. Whoops, let me get my pen set up. Okay, starting on 14 today. Use differentials to approximate the square root of 38. Use differentials to approximate the square root of 38. I wonder whose phone that is. Okay, good. All right. That's kind of a nebulous question. Oh, I meant to say this too. Remember that one? Number 11 that we were talking about that had the point not on the curve? Yeah. Dr. Thomas said they threw that one out. They did. Yeah, they didn't realize somebody had typed in something wrong, and so they threw it out. So, all right.
All right. I made a 10 out of 39.
That's better. Yeah. All right. Use differentials to approximate this. Okay.
Yeah, see that the directions on this one, I just skipped.
Yeah, and I can see why. I think I know what they're talking about. Let's say let f of x equal the square root of x. Okay. Then I think that's the way we want to go. Then f prime is equal to negative 1/2 x to the minus 1/2. Okay, and then we would say dy is equal to 1/2 x to the minus 1/2 dx. Okay. Now, here's what I think they're heading toward. What we're looking for is y, or dy, delta y, is equal to 1/2. And what we're going to do is plug in x equal 36. Okay, because that is a perfect square. Right. Okay, so it'll be 1 over 30, the square root of 36, times the delta x is now 2. Okay, dx would then be times 2. Okay, and those go out, and this would be, the change of y would be 1 over 6. Okay, we know that the square root of 38 is 6, so that would be, say again?
You mean 36?
Square root, yeah, square root of 36 is 6, so we're going to add 1/6 to it, so 36 plus 1/6 would be our approximation for y, and that would be 36, wait, no, none of these look like that's going to fit. That would be 36 and 1/6, which would be 97, no, 217. None of these fit. I don't know. That would be my guess of how to say that. Basically the square root of 38 is square root of 36 plus a little bit. And actually, Dr. Thomas said the key is out there on the website now, on Blackboard or wherever they put it.
See if I can find it.
Yeah. So, you want me to move on to 15? We'll come back to this? Okay, while you're looking. So I'll go to the previous page, and I'll work on there even though. So this is number 15, even though it has nothing to do with a graph. Find the values of the constants a and b such that the limit below is true. And it's the limit as x approaches 0 of the square root of a plus bx over, minus 2 over x is equal to the square root of 2. Find the values of the constants a and b such that that is true. All right.
I'm on Blackboard now.
Yeah. There's a math team Blackboard, is that right? Or okay. Oh, this is minus root 2.
Here we go. With answers.
Number 14.
It's coming.
Oh.
Number 14.
Yeah.
It gives us, okay, yeah, so 11 was omitted, but 14 is D, 37/6.
Is what?
37/6.
D, 37/6. That's the one.
Yeah,
Huh?
37/6.
Yeah. You said D?
Mm-hmm.
Yeah, 37/6.
It's like they had it like it was already over. If it was 36 over 6.
Oh, 36 and wait.
See, if it was over 6 already, then it would have been right.
Right. I don't think that one's right either then. Well, wait, no. 37 and 1, wait.
37/6.
No, that's, okay, I'm sorry. It's 6 and 1/6, not, I don't know where my brain was. 6th and 1/6. Okay, square root of this, okay? And 6 plus 1/6 is 37/6, yeah.
But how did you get it out of the denominator?
Well, this is 36/6 plus 1/6 is equal to 37/6. That's right. I mean, because the function was square root of x. We were having our x be 36, not 38, and then this would be the f of x, that's your change of y, is 6. Okay. If x is 36, then f of x would be, or
F of x is 6.
yeah. What I was trying to think of, weren't we doing something very close to this in, was it differential equations today, weren't we? Or,
Maybe.
yeah. And, you know, it's approximating, you know, the slope, you know,
Right.
yeah. It's that same type of a thing here. We make a guess and then estimate. This is our estimate. And the change is 1/6. It was square root of 36, which is 6. 6 plus 1/6 is 37/6. So yeah, that makes sense. I put in a 36 here rather than 6. Yeah, just a dumb move. Okay. All right. Then what I think I'm going to do, sorry about that, is do 15 here. I started writing it there, but it was a pain in the neck there.
So I do have the answers to check now. So
Huh?
I have the answers pulled up to check.
Yeah, okay. And that was one, and you got that one right, by the way.
Really?
Yes, or you have it marked here. Okay. 15 is the limit as x approaches 0 of the square root of a plus bx minus the square root of 2 over x is equal to the square root of 2.
Square root of a plus
Yeah.
bx
Right.
minus square root of 2.
Yeah. Now,
Plug in zeros for x to check. Right?
yeah, and of course, you have a something over 0, which would never be good unless that numerator is 0.
Right.
So that would be my first thing. The square root of a plus bx minus the square root of 2 needs to be 0 for it to be an indeterminate form, right?
Right.
Okay, so that means the square root of a plus bx equal root 2. Okay, square both sides, a plus bx is equal to 2. Okay, now,
2 minus a over b equals x.
second,
Well, I was saying 2, or well, it ends up being a would equal 2, right?
okay, yeah, a is equal to 2 and b is equal to 0. That certainly seems like that would work, okay? And I think that's the only one of the choices here that would. Let me see.
Oh, wait.
0, 0 certainly wouldn't work. A root 2 I don't think would work. 2 and 4
That would work.
yeah. No.
If
A is equal to 2 and B is equal to 4. That would be,
if x was 0.
yeah, but you don't, x needs to be a variable. Oh, wait. Yeah, well, that's true. Yeah, that's right. That
And
would work.
that's the one they come up with.
C?
See?
Huh. I don't see why D wouldn't work as well, but C certainly would work, because if x were going to 0, that would be going to root 2.
Well, let's plug it back in the original function. 2 plus 0, or square root of 2 minus square root of 2 is 0 over 0 is not equal to square root of 2.
Right. Oh, that's right. That's it.
Plug it back into the original problem.
Yeah, plugging back into that.
Because that worked for this case, but if you when you go plug back in,
It doesn't work. Got it. Yeah. All right. There's 16. A is equal to 2, B is equal to 4, not 0. It doesn't erase when it's supposed to erase.
Why don't you just erase all?
Okay. Huh?
I was going to say, why don't you just erase all?
We are going to, but I just wanted to clean that up for whoever may be watching. This is number 16. Find the values of the constants a and b that result in f of x being differentiable and continuous. So f of x equal to 3 cosine x when x is less than or equal to pi halves, and equal to ax cubed plus bx squared when x is greater than pi halves. Okay. Now, that is a cosine. It doesn't look like 3 oohs. No, x.
It does look like.
Okay. What we want for this to be continuous and differentiable,
They both have to be the same at pi halves.
at pi halves. So number 1, 3 cosine x, no, 3 cosine of pi halves has to be equal to ax cubed plus bx squared.
But
Well, wait. Okay.
I was gonna say
A times
it has
pi cubed over 8 plus b times pi squared over 4.
the only thing about it though. 3 cosine x is at pi halves, and the other part of it isn't at. It's just leading up to, right?
Right, but for them to be continuous and differentiable, they must touch there and be the same there.
Okay, so
Okay,
it's
so
not included in this function.
right, but it would have to meet that criteria. Okay, so let me see if I can say that a little bit better. Cosine of pi halves, by the way, is 0. Okay, so this is saying that
0.
a, make sure I did it right, a times or pi cubes over 8a plus pi squared over 4b is equal to 0. Okay? One equation, one unknown. Can't quite handle that, right? So, but now what would we do? Huh?
2 unknown.
Yeah, one equation, two unknowns, right.
Find another equation.
And what would that be? It says it must be continuous. This handles continuity. What handles differentiability? Derivatives must be equal too. So f prime of x is equal to,
The whole thing.
yeah,
That would be
negative 3 sine x from x, I can't write, less than or equal to pi halves. And it would be 3ax squared
plus 12x.
No, that's a 2.
Oh, that's a b. Sorry.
Oh, yeah, okay. Yeah. Making fun of my writing. I got that. Okay. Mm-hmm.
I was looking at my writing.
Oh, I see. Okay.
Like a 6 in my writing.
All right. Easy out there. Okay.
Also equally true.
Hey. 2bx or not. Yeah, okay. You're getting them. Okay. Pi halves. Okay. So what can we say here? Minus 3, because sine of x, sine of pi halves is 1. So that would be minus 3 must be equal to 3a pi squared over 4 plus 2b pi over 2. Okay. Yep, those 2's go out. Yes, you got it. Okay. Sort of sick mind you have, you know. All right, so let's write this in a system of equations. Pi cubes 8a plus pi squared fourths b equals 0, and this one would be 3 pi squared fourth a, what were you going to say? Plus b pi halves, no, pi b. Pi b, why do I write b pi? I don't know. Okay, let me get this cleaned up. Okay, pi, all right, pi b is equal to negative 3. Okay, now you got to figure out what we need to do to eliminate a variable. It looks like to me B would be easier to eliminate than A.
Yeah.
A little bit, not much.
Square and then divide by 4.
Okay, wait, okay. What do you have to multiply by?
You can multiply by 4 there.
Okay, 4 over pi.
4 over pi, okay.
Well, let's see. Is that necessary?
Because it'll knock out.
And then multiply this by minus 1?
Yeah.
Okay.
That'll work. Let me get to a clean page here.
Okay.
And then your V's go out.
Okay.
We're not going to talk about what they can do. Okay.
So this will be 2 pi fourths. So this will be minus pi fourths pi squared. Fourth A is equal to 3. And divide by pi, so A is equal to minus 12 over pi squared. Okay? And then,
go back and find B.
Yeah, and which one do we want to use?
Probably the bottom.
Okay, if you say so. That would be, no, it's fine. I'm just trying to read my writing here. That's 3 pi squared over 4, isn't it? Not 3, yeah, okay.
Right, because I wrote it out like that and realized that wasn't.
No.
It is.
Yeah, it's all times, yeah, okay. So it's 3 pi squared over 4 times a negative 12 over pi squared plus pi b equal negative 3. And here the pi squareds go out. Here so that looks like this will be negative 9 plus pi b is equal to negative 3. So pi b is equal to 6, and b is equal to 6 over pi. That is correct. So that looks like that answer is A, right? That is one long problem.
No, that's one that you just want to kind of skip.
Okay. All right.
I don't think I worked that one out.
You didn't get it right if you did. Okay. You may have guessed D.
Yeah, I think I guessed.
Okay. All right. So let's erase all that one. You got it?
Yeah.
17.
I only got 10 right. So.
Right. Okay. Consider a circle given by the equation of x squared plus y squared equal r squared. Okay, that is a circle. The graph of the circle has two tangent lines that are parallel to the line y equal x. Okay?
I guessed at this one, but I'm almost sure that I got it right. Well, let's say I guessed at it. I thought it through.
There's the line y is equal to x. Should be on the, so one of these is here, and one of them's there.
That's the exact diagram that I drew on my scratch work.
Oh, then I must be doing something wrong. Okay. All right. Find the points at which those two lines are tangent to the circle.
The points,
Okay.
Right?
The points,
Well,
right.
It's going to be, all So your second and fourth quadrant.
right?
So you have a negative x and a positive y, and then a negative y, a positive x and a negative y.
Right. So, you got it right. I can see that.
Which one did I pick?
C.
Yeah, that's it.
Yeah. And that is, because that's on that line, which is the negative of the thing, and this would be the x and y values are the same except for the sign. Here, x is equal to square root of 2 over 2 r, and y is equal to negative square root of 2 r, and up here x is equal to minus square root of 2 over 2 because it's a 45-degree angle, r, and y is equal to positive square root of 2 over 2 r.
Unit circle since they didn't define the radius.
Yeah. So anyway, that's the only thing it could be without using any calculus at all. Okay. It's doable.
Kind of look close, but not quite.
What's that?
I said D was close, but not quite.
No.
The square root of 2 comes from the
45-degree angle. Sine and cosine of that. Very good. Okay. You could use calculus to do it, but it's not necessary.
Why bother?
Yes. Except we love our calculus. Okay. This is number 18. The graph below, let's go to that.
Have you ever heard the song Love Stinks?
Is what?
Have you ever heard the song Love Stinks?
Love stinks? Is that what you're saying about calculus? Okay. All right. The graph here represents the velocity of an object moving horizontally on a straight path. Which of the following are true? Let me see if I can get this in for you. 0, 0.
Oh, this is another one of these. I probably
Yeah. 2. See, 1, 2, 3, 4, 5, 6, 7. It's going up to 10, so we're going to have to do 2. So this would be 2, 4, 6, 8, 10, 12. Okay? And up here we're going 7. Okay. Let's do 5, 10, 15, 20. That's about the best I can do. You might be able to expand it a little bit. Okay. So at 2, it's going to be about 12, I would say, but it's on its way down.
Yeah, there's a peak right before
Peak before that. At 4, it's going to be 0. Okay. At 6, it's going to be about 12 or 13 minus 5 minus 10 minus 15. So at 6, it's going to be right about there, I think. And peaks just shortly below that. At 8, it's going to be about the same place, maybe a little lower.
I'd say about the same.
Okay, close enough to being the same. And at 10, it's going to be 0 again. And at 12, it's going to be awfully close to 20. Okay, now let's see if I can come close to representing a curve that's not really all that good. Something like that. Not that, but something pretty close. All right. The graph below this shows the velocity of an object, and this is velocity as opposed to, I assume, time. They don't label that, but I think it has to be. Okay. Roman numeral little I says the object is moving to the left on the interval from 8 to 12. From 8 to 12, not. Okay?
Yeah.
It's moving to the left from 8 to 10 and to the right from 10 to, oh, I put this in the wrong place. There's 12. So this should be like that. Okay. And it didn't quite get down to minus 15. So my drawing's not quite. So 1's out, right? The object is only stopped at t is equal to 4. No, not only. Okay, yeah. Has velocity of 0 at 4 and 10. So that's one's out. Number 3, the object is speeding up on the interval from 4 to 6.
That might be true. Well, its
yeah.
acceleration is increasing, right?
Okay. Well, speeding up would be the magnitude of the acceleration is positive. And 4 to 6, it's going fastest at 4 and slowing down from there on, as far as speed. Okay. 4, the object is slowing down on the interval from 8 to 10. Slowing down.
I would say yeah, because remember it's acceleration, because when you're approaching that peak, all you're doing is slowing down, but when you're approaching the trough, you're speeding up, because you're about to change back to going to positive velocity.
Yeah. But slowing down is referring to speed, not to velocity. Okay?
Decreasing velocity.
Okay. And from 8 to 10, I'd say it's speeding up because, wait. Yeah. You see, there's the tangent line there, there's a tangent line there, there's a tangent line there. That is actually increasing in speed and velocity. So I'm guessing it's none of the above, none of these. E.
Which number? 18?
18.
It's C.
It's what? C. Maybe I misread. Oh, wait, I missed that completely. Okay, I missed C. Okay, sorry. 3 and 4 only. I still think I disagree with this. The object is speeding up on the interval 4 to 6. Okay, wait. Sorry. I was thinking this was a displacement curve. This is velocity. Sorry. It's going from 0 to 6. Yeah, it's going from 0 to some number. It's negative, but it's still speed. Yeah, it is speeding up from 4 to 6. Yeah, these are velocities. These are not, yeah.
Horizontal.
I was doing...
It's like one dimension.
I know, but this is speed, not displacement. I put V there and then... Yuck. Okay. And then 4 is the object is slowing down on the interval from 8 to 10. From 8 to 10, yeah, it's going at a large velocity. Yeah, and it's not to do with the derivatives. This is the velocity here. The speed here is minus 13, and it's at 10, it's 0. So that is slowing down, yeah. I was thinking this was a displacement curve. This is a velocity curve. Yeah. I don't know if you made a mark here. Oh, yeah, you put E, none of the above.
See, I was thinking the same thing.
All right. Sorry about that.
More familiar with displacement.
Yeah.
Yeah, displacement than velocity.
All right. We're going to erase all that and go to...
And pretend it was never there.
Yeah. Okay.
So
19. Suppose f of x is an even function. Okay? Which of the following is or are equivalent to the integral from minus a to a of f of x dx? Okay? Which of the following is or are equivalent to that? And then they have 4 choices. Yeah. Roman numeral I is 2 integral from minus a to 0 f of x dx. 2I is 2 times the integral from 0 to a of f of x dx. And 3I is minus the integral from a to minus a of f of minus x dx. Oh, man. Okay.
Well, so looking at this,
Okay.
the first one is the first two are cutting it in half.
Okay.
Right?
Yeah. But let's draw a function, an even function. Let's just do the cosine function.
Oh,
Okay? What were you going to do? X squared. Okay, parabola. Doesn't matter. Okay? So the integral from minus a to a of that even function is going to be the area under the function wherever that is. Okay? Whatever you do is going to be that, which is twice from, yeah, twice from minus a to 0 or twice from 0 to a.
Right.
Okay. Now, the area under here, an even function, f of negative x is equal to f of x. Okay? But if you flip these, you also negate. So, all three of these are correct. I'm guessing D. And that is the answer. Yeah. Because you see, number one, the even function f of x is equal to f of negative x. That's true. But any integral that you reverse so these two are the same. And if you reverse the limits, then you negate the interval. So,
I got that one wrong. So
yeah.
wrong. I see it now.
Yeah. But you got two of them were right. The two you said were right, but the third one's right also.
Yeah. I saw the whole having it.
Right.
Yeah, it's the same.
Yeah.
And I was like, I just wasn't sure. There's two. I saw the switching it and then negative. I got that. It was
Yeah.
the x being negative on the inside kind of threw me.
Yeah. Yeah. For even function f of x is equal to f of negative. See, this is equal to that.
Yeah.
Yeah.
I just
That is equal to that. You know.
should have
So,
drawn a graph.
right. Always. Okay.
Oh,
When it helps. Okay.
when it helps.
Which
Not
most of
in
the time it
space.
does. Say again.
Don't draw 3 space.
I can't hear.
3 space.
Oh, no. Yeah, let's not say we did. Okay, find this. The integral of x cubed plus x squared plus x plus 2 over x squared plus 1 times x squared plus 2 dx. Okay. What would be your approach? No.
That's the easy way.
Yeah.
Partial fraction.
Partial fractions, by all means. Now, partial fractions only works.
This is the one. This is the
Yeah. What?
I remember doing this one.
Yeah.
It gave me issues.
It gave you what?
Issues.
Issues, okay.
Unless you have a different.
Okay, but here's partial fractions. They only work when the degree of the numerator is less than the degree of the denominator.
That's why it didn't work.
No. This does fit that. This is degree 3. These are degrees 4.
Oh, okay. Well, then
So, yeah, it does
so
work.
it wasn't that.
Okay.
Something else.
So if using partial fractions, what we're going to say is we're going to try to break this down, and this would be that's in there. I don't want to write it again, so I'm just going to write it over here. That's going to be ax plus b over x squared plus 1,
Let's see.
right?
Yeah.
Plus cx plus d over x squared plus 2.
I'm sure you can guess what I did.
I'm afraid so. Okay. All right. That's
Doesn't work so well with just A and B.
no, not at all. You have issues. Okay. So that's what we're hoping this to be. So what that gives you is ax cubed plus 2ax, right?
Right.
And you can't do the little simple thing by setting x equal to something because it just doesn't work. but
Yeah,
yeah,
exactly. Because it
right.
knocks everything out.
Yeah. And then you also have a plus bx squared plus 2b, or not, okay, is equal to cx cubed, let me get these in the right order this time, plus dx squared plus cx plus d. And that's supposed to equal to x cubed plus x squared plus x plus 2.
Yeah, little sleight of hand there.
Okay, so let's get our cubes together. So a plus c is equal to 1, because those are the cube. Oh, wait. That's a plus in between there. That's not an equal sign. So where did that come from?
I don't know.
Okay.
But I wrote it too. So
Yeah, well, don't. Okay, all right. So that's equal to 1, because these coefficients of x cubed have to be that coefficient, which is 1. So that's one equation. Here's another, the squareds. B plus D is equal to 1. And 2a plus c is equal to 1. And
2b
or
d
plus d is equal to 1. No, 2. That one's 2. All right.
Or not to be.
Yeah. Now, if you take these two together and subtract, you get that a is equal to 0.
Right.
Okay? And that means c is equal to 1.
Right.
Okay? Subtract this one from that one, and you get b is equal to 1. And that means d is equal to 0. I think. Yep. Okay? Let me make sure. Yeah. Yep. Okay. So now we can write our new integral, and this is an indefinite integral, as 1 over x squared plus 1 plus x over x squared plus 2 dx. By that?
Yes.
Okay. Now, this is an arctangent. The first one. You don't look like another issue, I think, coming up here. Believe that's right.
1 over x squared plus 1.
Yeah. You want to work it out?
I'll believe it.
Okay. Believe that's an arctangent. So I think that's going to be an inverse tangent of x. Believe it is.
Are you talking about taking the integral of it?
Integral of it, yeah.
Yeah, that looks right.
Okay. This one we can do a substitution. Let u equal x squared plus 2. Then du is equal to 2x dx. Divide by 2. And this will be a plus 1/2. And that would be the integral of du over 2, right? Yeah, x dx is equal to, okay. So that would be the integral of,
du over 2, right? So
I mean du over u.
yeah,
So that'd be log u. Okay, so it's inverse tangent of x plus 1/2 the log of x squared plus 2 plus c. Do any of these seem to fit?
Which number is it?
This is number 20. Okay, number 1, you can rewrite this as log of the square root of x squared plus 2.
That's it.
But this is inverse tangent of x plus that.
And that's the answer.
Ah, that's A, isn't it?
Yep.
Okay. Yep, that's the correct one.
Right.
Good. Okay. They wrote it as arctangent rather than inverse tangent, but it's still there. All right. Ready for 21.
Only barely.
What am I doing here?
I wonder the same thing.
Okay. 21. Okay. Consider the plane region, that's a P-L-A-N-E as opposed to P-L-A-I-N, plane region, bounded by x squared over 9 plus y squared equal 1. Okay. What's that?
What did I get for this?
What, the last one or this one?
This
2 pi c. 2 pi.
one.
Okay. Okay. Now first, what is that? Again, pictures worth
Isn't it
hundreds of
a
words. Nope. Not 9 down there knocks it out.
Be an ellipse.
Ellipse, exactly.
It says
Okay.
that probably.
Okay. Oh, find the volume of the ellipsoid formed when this region is revolved around the y-axis. Okay. So let's see if we can draw this. Your,
I thought we were going to pretend we wouldn't draw any three space.
what's that?
Thought we weren't going to draw any.
Yeah, this is just slices. This is not really there yet. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1. 1. Okay. Kind of a scrawny little ellipse here. That's not really it, but something like that.
Yeah, I remember drawing this.
Okay. And because, yeah. Wait. Wrong.
Oh, the other one.
3 to 1. Okay, sorry about that. Okay.
See?
It's x over 3 squared. Okay. Now, check it and make sure that's right. When x is equal to 3, square 3, you get 9. 9 divided by 9 is 1, so at 9, at 3, 0, negative 3, 0, that fits. And at when x equals 0 and y is equal to 1, you got it. So that's it. That's your ellipse. Okay? Now you're going to revolve that around the y-axis. Okay? So you're twisting this around the y-axis. Okay? Now,
It makes a weird disc shape.
yeah, exactly. Sort of a flying saucer type thing. Right. Okay? Now, it appears to me to be, okay, find the volume of the ellipsoid formed in that region is revolved around the y-axis. It would just seem to me that we ought to be taking dy's. I don't think shells are going to be very nice here. So I think we need to do discs, right? Okay. Now, so we're taking a slice either place here, a slice here, and that's a circular slice because it's going around the y-axis. Okay, the radius of that circle is x, right? Okay. So pi r squared. So yes, exactly. Okay. So that's your, okay, but you need it in terms of y, sorry, because you're doing dy's, right? So since you're going to do a dy, you need to get this in terms of y's. Well, this gives that to you, doesn't it? That x squared over 9 is equal to 1 minus y squared. So 1 minus, I wrote minus 1. Okay, never mind. That's a y. Okay, got it? And then multiply by 9, and you get x squared is equal to 9 minus 9y squared. Right? So x then is equal to the square root of 9 minus 9y squared, which leads me to, you pull out a 3, which is 3 times the square root of 1 minus y squared. Okay, now that leads me to this next thing. Let's integrate only the top half of this and double it. Okay, because everything is same above and below. That way we don't have to mess with plus or minuses. We'll just use the plus. Okay, so that's our radius in terms of y, right? Okay, and that's basically all we're doing. We're summing all those areas as we go from 0 to 3 on y, right? Okay, so let's do it. The volume is equal to twice integral from 0 to 1, that's where y is going. dy is the thickness of that slab. The area of the slab is pi r squared, so we can put our pi out here. Our r is our x, and when you square that, you get 9, so that makes this 18 out of here times 1 minus y squared. Right? Okay, so this volume is 18 pi. Antiderivative of 1 is second y minus y cubed over 3, evaluated from 0 to 1. I'll do the 0 part. Okay, so this will be the 18 pi times
minus 1/3, which is negative 2/3.
just 2/3.
Right.
2/3. 3 will go into 18 6 times, 12 pi.
That's the answer.
Is it? Good for them. They got it right. All right. That was 21. You buy it?
You
Okay.
got any money to buy it with?
Okay. Good deal. It's cheap. Okay.
Do you want to go all the way till 4:45 with us?
Doesn't matter to me. You ready to go or?
I'm kind of tired.
Okay. So we did through, what was that, 14 to 21.
Yeah, we got 7 done.
Okay. All right. So we will close this now. Well, I'll go and erase all ink on the slide.